Today's tutorial will be on kinetic energy and potential energy and the conversion between them. So, who can tell me the definition of energy? The definition of energy. Something that has the ability to do work. And what is work? What is work?
Like the direction or the speed.
Yeah, anything that has a force acting upon it. So we say that forces act using energy, and when they're acting, they are doing work. Right? We're not going to go through all the different types, but because there are two general or two big types. There is. Oh, this one, mate. My board is moving. There is kinetic energy and there is potential energy. Kinetic energy is movement. So anything that is moving has kinetic energy. All right? And so there are, just in general, there are different types of kinetic energy. There is, of course, the energy of movement. There is heat. There is light. There is sound. Yep. There is electric. Okay, all of those involve the movement of something. Right? Potential is the storage. So there is gravitational storage, or GPE. Gravitational. There is chemical. There is nuclear. There is the most boring one, elastic. Okay, and they all store energy. And you can convert between the two. You can go from any form of kinetic energy into any form of potential energy, and you can also go from any form of kinetic into the others as well. So there's completely interchangeable. Does anyone know what we call the rule? Anyone here speak Spanish? What does LOCOE mean? Crazy. How do I spell my crazy is spelled differently than your crazy? Mine's LOCOE, which is LOCOE, but more LOCOE than your LOCOE. My LOCOE, LOCOE, is the law of conservation of energy. Isn't that crazy? Oh. The law of conservation of energy is energy can't be created or destroyed, only transformed. LOCOE. LOCOE. Law of conservation of energy. Matter can't be created. It can't be destroyed, but it can be transformed or transferred if you want. Transformed. All good? But today we're going to concentrate on kinetic energy of movement and gravitational potential energy. All good? You're creating trouble over there. Right. Do you think your mum would be watching so she can tell if you're creating trouble at school? And you get home. Oh, Mr. Canine said you're creating trouble. Right, can I rub that off? Is that okay? Any questions? No? The different forms are very, very straightforward, and you do almost regurgitate what you need to know about them. Okay? So, lidless. Right, so kinetic energy. EK means kinetic energy. There's nowhere to sit.
No, I'm counting.
Oh dear. Is this too many? Is this above your limit? Right. EK, which is kinetic energy, equals a half mv squared. Another way to write that means exactly the same thing, is it's mv squared divided by 2. It's a little m, not a big M, and the little m means mass. And the units for mass are? Sorry? Kilograms. Kg. V is velocity. The units for velocity are meters per second, which means how many meters do you travel in 1 second? How do you calculate the velocity? Well, first of all, velocity is very similar to another word you might think about rather than velocity.
Gravity.
No, starts with S, ends in P.
Speed.
Velocity and speed are very much the same thing, except velocity is speed, but in a particular direction. Right? So you can be going 2 meters per second upwards, or 2 meters per second forwards. So the 2 meters per second is the speed, but because you put a direction in it, it becomes velocity. Okay? So velocity, the way that you calculate velocity is distance divided by time. We'll put S. S is distance divided by time. Okay? So if we were doing an example of this using this equation, you still at the school? I thought you were expelled. Oh. See, she's looking all prim and proper now. Right. So if I had, what? Do you have a dog? You don't have a dog? Do you have a cat? Oh, if you had said yes, would have never spoken to you again. Do you have a dog? I should get a sausage dog. You have a sausage dog?
Yeah, I have 2.
Benny and
Jerry.
Benny and Jerry. Oh, that's right. If Benny, how much do you think? How many kilograms is Benny?
I think 6.
You think 6 kilograms? Benny, capital B for Benny, is 6 kilograms. Okay, is able to run 10 meters in 2 seconds. Okay. What is Benny's kinetic energy? Ooh, is that a tough one? Is that a tough one? So, we know that the equation for kinetic energy is EK equals mv squared on 2. So the first thing we need to do is we need to calculate V. And we've got over here, we can write that V is S on T, so distance on time. He runs 10 meters in 2 seconds. So his velocity will be 5 meters per second. 5 meters per second. So now we know the mass, we know the velocity, and 2 is always 2. Yeah? So we can write over here, M, he was 6 kilograms, times, now squared means times by itself. So it's 5 times 5, or 5 squared, or 5 times 5, divided by 2. So that equals 6 times 25 divided by 2. 150 divided by 2. 75. And what are the units?
Joule.
Well done, joules. People sometimes like my J's. I'll try to make it look neat for you. All right? 75 joules. All right? So that's the simplest sort of equation or question you will get, but more often than not, they want you to transpose the equation. All right? Can I rub that off? Now, to transpose the equation, you do transposing an equation in mathematics. All right? And I'm going to teach you a sneaky way to transpose. All right, so I've got EK equals mv squared on 2. To transpose means that you isolate one of the variables. So at the moment, kinetic energy is isolated, and the equation is mv squared divided by 2. But we can transpose the equation, and yes, there is a proper way to do it, but we're going to do the sneaky shortcut. Right? So if we want to isolate m, we want m by itself. Yeah, which means we've got to put everything else that's with m on the other side. And the sneaky rule is if it's up the top on this side, it goes down the bottom of this side. And if it's down the bottom on this side, it goes up the top on the other side. Okay? So we want to get m by itself. So let's move the 2 across first. So it becomes 2ek equals mv squared. Yep. Now we've got to get rid of the v squared. Right. So we can write 2ek, because it's up the top on this side, it goes down the bottom on this side, divided by v squared equals m. There is a proper rationale for doing it. Yep.
Why did you put because the taste of bottom? Never mind.
Okay. I speak to myself all the time. That way I get an expert opinion. Is that your pet fly? Right. All good? So this is what we would use if we wanted to calculate m. This is the equation we would use. Okay? If we wanted to calculate velocity, if we wanted to get v by itself, we would then get rid of the 2 first. 2ek equals mv squared. Yep, but now we want to get rid of the m to leave v by itself. So it becomes 2ek. Remember, it's up the top. These are on 1. So these are at the top at the moment. When we put an m down the bottom, equals v squared. But now we've got to get rid of the squaring. And what do we do to it? Square root. So we know now that v equals the square root of 2ek divided by m. And so we're able to work out the velocity. We can go through the long, or we just know that that is the equation, the transposed equation for velocity. Is that okay? So all I've done is I've moved around the variables to isolate what we're trying to calculate. So we'll do an example on the board now about how or why we would use it. Now, there are 2 ways to understand it. One is to try and understand what I've done mathematically, or the other one is just to know that that is the equation for working out the mass, and that is the equation for working out velocity. And if I was in year 8 and if I didn't want to know about the mathematics, I would just learn that and that and that. It's up to you. But as you go through maths further through school, you'll get better at doing that. Okay? But once again, the cheats way of doing it is when you move it across the other side of the equal sign, it changes to the opposite function. So if it's times on this side, it becomes divided by on that side. Okay? And there is a longer way, a proper mathematical way of doing it, but we're just cutting to the shortcut. Okay? All right, so I'm going to rub that off. Is that okay? Right. So let's do here EK M the equation that we will use and the answer. All right? Harriet, your fly is annoying me. Harriet. Juliet, your fly is annoying me. Right, so here I want to know EK. The mass will be 10 kilograms. The velocity will be 7 meters per second. What equation do I use to work out kinetic energy? Well done. We're going to use EK equals mv squared on 2. So m is 10. V is 7. But remember, it's 7 squared. 7 squared divided by 2. What's 7 squared? 49. So it becomes 490 divided by 2, which equals 245 joules. Did I get on? All good? Now, if I had total energy, let's go for 1,000. 1,000 joules. And the mass was 20 kilograms. And I wanted to know the velocity of the object. What equation would I use? Claude, do you want to have a go? Which one of the ones I gave you would we use? V equals the square root of 2ek on m. Well done. So we know that V equals the square root of 2ek divided by m. All good? So now we just put the square root of 2 times EK, which is 1,000, 2, 3, divided by 20. 2,000 divided by 20? 100. And 100 square root? 10. Hey, I made up that example completely randomly and it worked out perfectly. 10 meters per second. I am very good at making up examples without meaning to. All good? Then if I had, how many joules can I have total energy? You've got to just pick a number. 27. That's going to be tiny. Very 6-7. Sorry?
That's my favorite number.
27. All right, I'll put that as the velocity. All right. All right. 41 joules. We don't know the mass, and the velocity is 27 meters per second. mustards. Right. What equation am I going to use? M, what equation am I going to use? So M is 2ek divided by v squared. 2ek divided by v squared. I don't think it's going to have a very large mass.
I think it will either.
So 2 times 41 divided by, here we go, 27 squared.
0.11.
Oh, equals 0.11 kilograms, which is how many grams? 110. 110 grams. All good? Any problems? As I said before, you can learn to transpose the equation or you can just know the equations. So these are the 3 transpositions of the equation. If you know them, you don't even need to look at a formula sheet. You'll just be able to go, bang, this is the equation I got to use. Yes? You probably will, but it'll probably just have the 2 main equations on there, being EK and EP. And then you might be expected to transpose them yourself. But if you just know how they transpose and you know what the equations are, then you don't need to waste time on it. Yep? So, that's kinetic energy, which is the energy of movement. Now we'll do potential energy. All right? And we'll do the gravitational potential energy. Right. So, now we're going to talk about a store of energy, EP, potential energy. In particular, we're going to talk about gravitational potential energy, which we can use EG. Okay? And the equation that we have to know is mgh. Now we know that little m stands for not marbles, mass. So m is mass. What's the units for mass, Olivia? Kilowhales? Kilograms. Kilograms. G is gravity. And what's gravity on Earth? 9.8. Well, 9.81 if you want to, but I'll just stick with 9.8. It equals 9.8 meters per second per second. What's another way of writing meters per second per second?
Meters per second.
No. Sorry?
Isn't it like meters per second minus 2?
No, it's not meters per second minus 2.
Isn't it just
It's-
meters minus 2?
No. You're in between both of those answers. Another way of writing this is not meters per second minus 2. It's ms minus 2. That means meters per second per second. So you might either see it as 9.8 meters per second, but most likely you'll see it as 9.8 ms minus 2, which means meters per second per second. What does that mean? What does it mean to have, yes? Sorry? Yeah, acceleration. Well done. It means that every second it's speeding up by 9.8 meters per second. So just say I jumped off a building. After 1 second, I would be traveling at 9.8 meters per second downwards. After 2 seconds, I'd be traveling at 19.6 meters per second downwards. Right? I would pick up speed, and the longer I fell for, the more speed I would have. Yep. So it's an acceleration. And then h is height, and the unit there is meters. All right, so we'll do an example. Ready for an example? Right. Mr. C, me. Oh, are you okay? Oh, looks like you were doing a robot dance. No? Oh. Mr. C, and my mass is 100 kilograms of rippling muscle. All right? 100 kgs of solid muscle. Fell down a hole. Down a hole that was... How deep was the hole?
10 meters?
What were you going to say? Were you going to say something? 20. You're going to say 20 meters. I'm going to fall down a 20-meter hole.
She said 2,000.
She said 2,000 meters. Ouch. Fell down a hole that was 2,000 meters deep. Okay, and we want to know the EP at the top of the hole. Now remember, potential energy is a store of energy. If there was no hole there and I was just on the ground, I would have no potential to fall into a hole that didn't exist. So if I was just there and there I was there and there was no hole, then I would have no potential energy. But because there's a 2,000 meter hole in front of me and I have the ability to fall down it, then I have potential energy. Okay? So at the top of the hole, how much energy do I have stored in me because I have the ability to fall down the hole? Oh, all right. So now we go up to Eg equals mgh. Mass is 100 kilograms of solid muscle is what you were supposed to say. 100 times gravity, 9.8, times the height or the depth of the hole now is going downwards. Sorry? 2,000. Now you'll need a calculator.
1,960,000.
Sorry?
1,960,000.
1,960,000 joules. I could do a lot of work. Especially if there was a turbine at the bottom that would spin a generator and make electricity. So down the bottom here, I could have a little turbine. And as I felt it spin and make electricity. Yes? Right. Any questions there? No? I'm going to rub it out. All right. So once again, we can transpose the equation. So once again, you can work out how to transpose it, or you can work out what the different equations are when we isolate each variable. So we know we've got EG equals mgh if we want to calculate EG. Yep. If we wanted to calculate M, so we want to have M by itself. Remember, these ones here are on 1. So they're actually up the top, not down the bottom. Yep. So we want to get rid of G and H because they're at the top here. They come down the bottom here. So it becomes EG divided by GH. Yep. If we wanted to isolate G equals EG divided by MH. If we wanted to isolate H, what would it be? What would it be?
EG over MG.
Well done. EG divided by mg. All good? So now what we'll do is we'll do EP, M. We don't need to put G in there because gravity on Earth is always the same. Yep. We can put G in there in case we talk about if it's on a planet, and then H, and then we can talk about the equation and the answer that we're going to get. All right? Does anyone have a pet llama? Olivia's got a pet llama. Olivia's pet llama has a mass of 37, or you said 36? 39 kilograms. Her llama is 39 kilograms. What is gravity on Earth always? Well done, 9.8. Is there any units on 9.8? Well done, ms minus 2. And it's standing on a building. How tall is the building? It's on top of your house. How tall is your house? How many meters?
She wants it as long as the phone.
Your llama is going to fall off the house. I just want to know how tall your house is. Do you live in a very tall house? 8 meters tall? Okay. On top of the house, it is 8 meters tall, and we want to work out how much potential energy it has if it should fall. Okay? So the equation, what equation are we going to use? MGH. EP, or EG, equals MGH. So it becomes 39 times 9.8 times 8.
Is this the one where you round to the nearest one?
Yes. Well, now we've got 1 decimal place, so it's got to be rounded to 1 decimal place.
Oh.
Has anyone got an answer for me? 3,057.6. 3,057.6. And the units? Joules. Remember, if you don't put the units in, you lose a mark. Okay? Does anyone here own a rabbit? Karis? Mizza? All right, you own a rabbit. Now, your rabbit, we don't know, we want to try and calculate the mass of your rabbit. Okay? Your rabbit, when it was on top of your house, it had We'll make it 2,000 joules of energy. Yes? Gravity on Earth, where your house is 9.8 meters per second per second. 9.8 meters per second per second. And the height of your house is?
6,700 meters.
That's tall. That's going to end up, we're going to really need a calculator for that one.
Oh, okay.
Can I just make it?
Like 607.
You know how numbers work? Right.
Yeah, 670.
607 meters tall. 607 meters tall. What equation are we going to use to calculate the mass of Mrs. Rabbit?
EG divided by.
Yeah, but what? We're going to start with M first.
Oh, M equals EG divided by GH.
Divided by GH. All right. So we know that the energy was 2,000 joules, 2,000 divided by G, which is 9.8, times the height, which is 607. Have you got a calculator, Emily? You're not a human calculator? I'm a human calculator, but the answer is always 1. Have you got the answer? You haven't done the answer?
0.3.
0.3. 0.3 kilograms, because it's mass. What's 0.3 of a kilogram? 300 grams. That's a tiny rabbit. It's a miniature rabbit. 300 grams. All right. What about if I had the EP, the gravitational energy, stored energy? Well, let's make this one 6,000 joules. Who here has a fish tank at home? You have a fish tank?
But my fish are all dead. I have a bird.
All right, just say you've got a bird who's fallen into the fish tank.
Oh.
All right, so going to about to fall into the fish tank. We want to work out the velocity of how it's going to fall into the fish tank just before it splashes into with all the piranhas and the sharks. Aren't piranhas fish? Aren't sharks fish?
What size fish tank are we talking about?
It's about the size of this room.
Oh, okay. I thought you meant like a tiny one.
Well, it depends on the size of your desk, really. If you've got a big desk, you can have a big fish tank. If you've got a small desk,
Then how big's the desk?
my desk,
Yeah.
or your desk, because it's, I think she's got a rather large desk. It's like a dining table. Got this big shark and lots of piranha in it. All right. We know that the mass of the bird is
90 grams.
500 grams. Do you not feed your bird?
That's an average weight for a bird.
Of an unfed bird, one that's been dead for a long time, is only going to be 90 grams.
It's a
And if you don't feed it, it gets very light. All right? We know that we've got 9.8 meters per second for gravity on Earth, right? But we don't know the height that it's going to fall from. We don't know the height that it's going to fall from. So what equation are we going to use? H? Is it H or H? Is it H or H?
H.
It's H or H? Do you say H or H? Do you say H or H? She said one H, one H. Do you say H or H? H. Do you say H or H?
I don't know.
You say H. So there's now 2 and 2.
I don't know. What
You don't speak our language.
Well, I'm like, if I'm saying
You don't speak your language. You You don't speak English. Do you say H or H? Sorry? H. H or H? Well, it's 3 and 3 now. Right. So, equals EG divided by MG. So now it becomes 6,000, 6,123, divided by the mass, which 500 grams is how many kilograms? 0.5 kilograms. Divided by 0.5 times 9.8. It's falling off a rather tall bookcase. Anyone got a calculator? Anyone know how to push buttons on a calculator? No? I think she's on the phone rather than calculating.
18.
It's 1,234.5.
That's a rather high bookcase. 1,224.5 meters. That's a big fall. It is 1.2 kilometers. What are you doing dropping a bird off 1.2 kilometers into a fish tank with sharks and piranha in it?
It can fly.
You are quite heartless. Well, it can't fly because now you've fattened it up. Before it was only 90 grams could fly around, but now it's 500 grams because you fed it, and now it just plummets.
Well, it was like 5 kilos. That's even worse.
Anyway. So, all good. Now we can do the last bit. What's the time?
It's 404.
4:04. We've got 10 minutes. You just give me a jeepers creepers. All right. We'll keep it simple. Ish. Ah. All right. So now we're going to do long way down, 1.2 kilometers. So now we're going to talk about the conversion of energy. All right. So, okay. If I've got, what am I going to have strapped to a roller skate? What's going to be strapped to a roller skate? What sort of animal are we going to strap to a roller skate? Oh, a cockroach. The cucaracha strapped to a roller skate. So here is a roller skate with a cockroach. All right. But it's a very big roller skate and quite a hefty cucaracha. All right. And its mass is going to be 2 kilograms. Okay, 2 kilogram cockroach strapped to a roller skate. In total, it's 2 kilograms. You could almost serve that as a meal in itself, that cockroach. Deep fried, yum! A little bit of bok choy, oh, delicious. Bit of garlic, oh, a bit of udon noodle, oh, lovely. Be delicious. Right, it is on that roller skate, and it will keep it simple for you. 10 meters above the ground. Okay? All good? Now, up here at the top, it has 100% EG. All of the energy is stored because it has the ability to fall. Good? And as it falls, it's going to be converted. So when it hits down to the bottom, we're going to have 100% EK. All of the energy can be converted into kinetic energy. Yes? So if we work out the amount of energy here we've got 100% EG, but 0% EK because it's not moving yet. Yep. We're about to give it a bit of a nudge. And then when it gets down to the bottom, it's going to have 100% EK, but 0% EG because it can't fall any further. Yes? So here, if we want to work out EG, how would we work out the total energy stored in the cockroach strapped to a roller skate? What equation would I use? What equation would I use? Is there anybody out there? MGH. MGH. The mass is 2 kilograms times gravity times the height of 10. Anyone know the answer? You've given up calculating. Your fingers are too tired after a day at school. But if you keep calculating, you'll end up with really rough buff fingers like this. Look at this finger. Oh, look at that finger. Oh, so strong. Now you can go home and see my super strong finger. What's the answer? 196 joules. Okay? Now with the complete conversion down here, we don't have to work out EK. We can just know that all of that energy has been converted into kinetic energy. So we can say that EK here is 196 joules as well. But here's a sneaky bit. Here's a sneaky question, a hard sneaky question. If this here, from there to there, is 5 meters. So it's gone down the bottom here, it's rolling really quickly, and it goes back up the hill to something that is halfway. It's going to have 50%, so it's been returned 50% EP, and we know that we're still going to be moving, and we're going to have 50% EK. It's gone back up again. All right with that? Now what we're going to do is try and work out the velocity of the cockroach on the roller skate here. We want to work out the velocity. Yes?
Is it EG or EP?
Same thing. Well, EP or EG is a type of EP. EP is potential energy, and a particular type of that potential energy is gravitational potential energy that we write as EG. They're interchangeable if you're talking about gravitational energy. Okay? So what's the equation that we're going to use? Are you tired?
Yeah.
Gee, it's been a hard day for you, has it? Like a week back at school? Yes? Sitting around outside all the time? You guys are working very hard. All right. So we want to work out the velocity, and the equation that we're going to use is the square root of 2EK on... Are you checking that I've got the right equation? On M? Is that the right equation? You're too tired to speak. Too tired to speak? Too tired to move your lips again. Right. Now we know that we're going to have the square root of 2 times EK, and EK here, we've only got half the EK. So what's half of 196? I think it's got a 9 and an 8 in it.
98.
You are quite quick. It's not true what they say about you at all. 98 divided by the mass, which was 2 kilogram cockroach on a roller skate, divided by 2 is going to be the square root. 2 and 2 will cancel. The square root of 98. Square root of 98. It's nearly 10 again. 9 point. Is it 9.8 or 9.9? 9.9. And the units? Well done, meters per second. So as the cockroach is on this part of the track, it's travelling at nearly 10 meters per second. All good? Right. Must be 4:15. 4:13. I've got to finish 2 minutes early.
My dad's here.
Oh, okay. Has he got the bird in the car with him? That really skinny bird you haven't fed? Or the fat bird you did feed?
That's a normal weight for the bird.
What, 500 grams?
No, 90.
90 grams?
For the bird I have here.
You should feed it. Feed it another bird. Give it bits of chicken.
Thank you.
All right. All done. Goodbye.